afternoon to everyone today. Welcome to the Esri Virtual Fireside Chat series with GeoWorks. Today's topic will be talking about spatial thinking for rookies. Together with us, let me welcome our fellow panelists today. Interestingly, we have three panelists with us today, and they are actually from they have different backgrounds. So we have one who is an educator, one is a student currently, and then we also have an industry practitioner, a veteran, I would say a veteran in the GIS industry. Without further ado, maybe I'll welcome them into this fireside chat. Can we have our fellow panelists online, please? Welcome on board, Noel, Yuting, and Clinton. So maybe I'll just give a quick introduction. So we have Noel Chang, who is actually an educator. He's a geography teacher, currently teaching in Sengkang Secondary School. And he's also the winner of the Award 2021. We have a graduate student who is Su Yuting. She's currently in NUS right now, studying Masters of Science in Applied GIS. And then we have with us Clinton Libby, who's the Managing Director of Umi Analytics Private Limited. Okay, so welcome on board, everyone. Let's make this very casual. We do have quite a number of audience with us today. Let me kind of kick off the first question, and then we'll open up to anyone who wants to start first. Okay. Firstly, tell us a bit about yourself, or in Clinton's case, about your company, and tell us what does spatial thinking mean to you, and then what was actually your Eureka moment that made you adopt GIS in your line of work or field of study? So yeah, so I'll open this up to anyone who wants to start first. Or do I have to select one of you? Let's start off with the. How about we start off from a student's perspective first. Yuting, let's start off with Yuting. Okay. Let you have the floor. Yeah, do share with us.
Okay, hi. Thanks, Aja. So, hi everybody. Good afternoon. My name is Yuting. I recently completed the Master of Applied GIS program from the NUS. And right now I'm working as a GIS specialist in Esri, Singapore. So I'm very happy to be here today to join this community of geospatial practitioners and people who are interested in geography, geospace as a whole. So I'm happy to be here to share maybe a little bit of my thoughts. So as some of you might know, Esri Singapore, we are the local distributor of the GIS products on our GIS platforms. So besides as the local licensor of software, we also do a lot of these consultancy services and GIS implementation projects with our clients. So these projects can range in different sizes and different shapes. Some of them can be as big as national spatial data infrastructure. Some of them could be as small as helping a firm setting up its mapping platform, for example. So I was telling Aja the other day, the question of what was the Eureka moment that made me adopt GIS in my line of work, in my field of study. I think GIS or spatial thinking is really the core of everything we do. So there isn't really a moment where I can think of space is not important to us. Every time when we do things, spatial thinking is always important. So to me, I think spatial thinking is really about adding the dimension of geography in everything that we do. So I think it boils down to a few simple ideas that hopefully everybody can relate to. So the first is definitely everything that we do takes place somewhere in space. So everything, almost everything has a location component in it. And then if you relate this back to your daily life, if you relate this to the business owners, if you relate it to different parts of your business processes, you will see how location comes in. So for example, where your storage house is, where your warehouse is, how your distribution network is being structured, all these has a location component in it. So that is the, to me, that is the most important idea. And secondly, it comes back to, because everything has a location in it, therefore, the fact that locations or places differ from one another makes a difference to the way your business works. So for example, for people who work in bigger firms, sometimes we structure our operations into different markets. So the fact that we call ourselves, you are managing the US market, you are managing the Japan market, implicitly you're actually recognizing that because they are in different places, therefore you actually need specialized knowledge or specialized skills to handle operations in that particular market. So that in itself, I think, is also spatial thinking in the play. So really, I think is pretty important to every single thing that we do.
Thanks, Yuting. So perhaps maybe let's hear from Noah, from the perspective of being an educator in Singapore. So tell us a bit about yourself, and then how do you actually go get yourself into this spatial thinking, especially when it comes to relating it to students, especially how do you do it? So Noah, go ahead.
Yeah. Hi. So my name is Noah. I'm currently a geography teacher at Sengkang Secondary School. Same as Yuting, I'm very fortunate and thankful to be here today to share some of the thoughts and perspectives about spatial thinking. So I think at the very core, I think spatial thinking is really a process of sense making. Okay, some of the pertinent environmental issues confronting our world. So I guess when we look back at our own teachers, or maybe your geography teachers, I think the best teachers are not the ones who deliver PowerPoint slides. But I guess they are really the ones that brought learning to life. So to me, I think spatial thinking, how does it look like in the classroom or in general? I think one thing that I've learned using GIS is that spatial thinking does not take place in a vacuum. Spatial thinking also does not take place naturally when you are given a body of text. So if you are given 50 or 100 words, you don't start thinking spatially. Yeah, it's only the question that makes spatial thinking possible when you are given a text, right? So for me, spatial thinking takes place when you are given a visual or an audio stimulus. So I believe that, and I really feel strongly about this, is that when you can replace a paragraph of words with map resources, and you do that and run it in the classroom, I find that very powerful. So I think that's spatial thinking in the classroom. It's really about sense making the world, and that is only able to take place when students are given visual stimulus. So I guess if you say Eureka Moment, I think my turning point was when I interned at the Curriculum Planning and Development Division. And I got to work on some policy projects and help design some map resources. So I guess one of my mentors showed me how I can overlay multiple layers of spatial information and showed me how I can do that in a classroom. I guess that was my turning point, because in university, I'm taught to use GIS as academic geographer, but when I'm in the classroom, I didn't really thought about how I can get students to use GIS. So for me, it is the process of representing data about environment, showing it to our students, getting them to think about some of the pertinent environmental issues. I guess that's where it helped me make sense of my purpose as an educator and how I can do that in the classroom. Yeah, so that's why I feel like GIS has an important role to play in helping students find meaning and purpose in learning geography. Yeah, so that's my point. Thank you.
Thanks, Noah. Let's hear from Clinton. Well, Clinton geographically has traveled, I think, quite a distance from the US, and now he's back in Singapore. He's currently safely serving quarantine, right, Clinton?
Yeah.
So let's hear from Clinton, who's actually a veteran in this industry. Let's hear from Clinton on what gets him into GIS and what makes him tick and what's his Eureka moment. Clinton, over to you.
Sure. So thank you. And yeah, it's interesting. Spatially, I'm in quarantine, right? So I'm close by, but there's a barrier. and there are ways to build those models into a GIS. So you could have a dead end road, if you will, that doesn't connect, which is very often different than as the crow flies. But a little bit about me. I started in the mapping space, mostly on the remote sensing side. So I came from the satellite imagery side of the whole mapping industry in GIS. And, one of the things I think for me in terms of where I find the most, I guess my Eureka moment would be when we were first working with satellite imagery. I was very lucky to work with one of the inventors of digital image processing. He built the first image processing system for NASA in the 50s. And, he used to always tell me that, classification and unsupervised classification is really when we'll get to the point of being able to scale out and utilize imagery quite a bit. And so I would say that was one of the big Eureka moments. And then the other one for me was when Google Maps came out and provided navigation free of charge. And all of a sudden, the entire industry was shocked. Everyone from Esri, the Garmin's, all the navigation tools were like, you're giving away the stuff that we've been selling. And everyone in the industry was actually quite upset about it initially. But what that did is it opened it up to the masses and really increased people's spatial awareness, across the board. So you didn't have to be a GIS or remote sensing satellite imagery person, or even a technologist to understand the benefits of having easy access to maps and being able to use location information to help you achieve your objectives much more efficiently. And from that, a wide range of new applications have come out that enable us to really, it's expected, if you will, to be able to provide a map. And one of the things I think is a really interesting aspect, and I'm probably the oldest one on the call, so when I was younger, you could very easily get lost and have no idea where you are. Today, it is actually very difficult to truly be lost. Whether if you have your phone or someone else nearby has a phone, there's always a map nearby, and being able to show me exactly where I am on that map. And that provides a level of comfort, but also it enables us to explore more and to go after new things and understand our relationship with the environment around us at a much higher level. And once that happens, then we all start thinking about, well, how far away is it? How do I get there? Or if I'm a store owner, where is my inventory and who buys that inventory. If I have stores all over in different regions of the world, I may shift my inventory based on the local preferences. So it's not only, where I have my inventory, but it's also where my customers are and the regional desires of those customers. So that adds another element to it where I start tying in the geographic psychological aspects of what products would sell more effectively in one market versus another. And then, obviously, I think the biggest thing that we're seeing now is a resurfacing, if you will, of environmental initiatives. Initially, in the industry, it was very much defense and environment. Those were the two markets. And transportation, telco is also there, but it's really broadening out to a much wider range where we start having, a lot of logistics applications and a whole range of new applications that allow us to leverage the technology. And that's what's really exciting about, I think, this market right now. We're starting to see a transformation where maps are expected. Maps are a major component in any corporate strategy. It's become a requirement, if you will, for any technological leader to have some understanding of spatial awareness and spatial thinking. So I think we're on a verge of a spatial revolution, if you will, where location is the new black, so as they say. It used to, when I first started, just to go back, I would try to explain people what a satellite image is. And it would take me, a good 15 minutes to try and explain it. Now we all have, them on our phones, and we can flip through hundreds of satellite images in seconds, and it's all available to us right now. So very easily and quickly, and at no cost, even further. So that in and of itself enables that spatial thinking to actually manifest and provide us with a better understanding of where we are in the world.
Thanks. Thank you, Clinton. I think it's a very, very wonderful, great insights in terms of how wide right now the geospatial is actually being applied across industries, and the question of where anything is, it's very fundamental to a lot of decision making right now in a lot of corporations, companies, organizations, and so on. Thanks so much. Thanks for sharing. We have let's move on to the next question. So, what are some of the valuable skills and learnings that you have gained from using GIS? What are some of the challenges that you have encountered during this journey? What do you think of GIS today, considering new developments? For example, as what Clinton had mentioned, the use of imageries, and right now we have systems that are able to handle a lot of data. So we have how do you bring in time dimension, and then with the deep technologies like artificial intelligence, machine learning, IoT sensors, and smart devices. So I'll open this up to who wants to probably start first and have a chat about it.
Maybe I hop on first,
Okay.
because I was listening to Clinton's sharing just now, and something that I really like about what he said is that you do not have to be a GIS user to access maps. I think I can relate with that quite well, because at MOE, I don't think we are trying to teach students how to use GIS. I think the focus of the geography education is to get students to think more spatially and to get students to be aware of the environment. So I can relate with Clinton because it is easy to be carried away with the technology that GIS brings, but we often forget that GIS does bring a lot of learning possibilities in the classroom with regard to the environmental issues that we are facing today. So in response to your question, I think that let me first say that I don't think I will hold myself to a gold standard for using technology such as GIS in the classroom. Okay, but I do know that there are many experienced teachers who are very creative in their use of technology in class. So that's where I feel that, for instance, at MOE, we launched the MOE EduGIS in 2018, which is essentially an ArcGIS online platform for teachers to create and use these maps in class. Yeah, so for the past 2 to 3 years, teachers have come on board, and many of them have tried using ArcGIS online in class, which do not require teachers and students to have a lot of GIS competencies. Rather, the focus is on producing map resources that can be used for teaching and learning. Yeah. So what are some of the valuable skills and learnings that I've gained from GIS? So I guess for me, there's one thing I like to emphasize since I got the opportunity to, I think is that at MOE, I think we teach geography, but I think at the heart of what we do is that we teach students. So yes, while we use technology to engage our students, technology is not the center of our lesson. So what this means is that teachers should not be teaching the technicalities of the software, but focus on how technology achieves the learning outcome. And for this instance, spatial thinking. So, so in that sense, the GIS itself takes a backseat, but I think the values that we impart to them really take center stage. So what I can relate with Clinton just now is how GIS can really help people understand the relationship with the environment at a higher level. Yeah, and how it is important for any market leader to be familiar with spatial thinking, because everything has an element of space, everything has an element of location in what we do. Yeah, so for me, I'm really excited about GIS and its developments, because at MOE, we will begin the National Digital Literacy Program, which in other words, it means that all secondary students and JC students will own a laptop or a personal learning device by end of 2021. So by end of this year, all students will get to have a laptop in classroom. So for me, I'm really excited because right now, if I would like to show students some of the digital maps that I have created, they either use their handphone, which the screen is really small, and some of the devices do not seem to be able to show some of the digital layers, such as the remote sensing layers. So I have to bring them to the computer lab, but if people have booked the computer lab earlier than me, then I can't use the computer lab too. So for me, this presents an opportunity when all students get a laptop. The power and the ability for teachers to use GIS would definitely be much more pervasive. So I think that's where more students can use remote sensing imageries, can use some of the spatial layers found on ArcGIS Online, and also some of the data layers provided by various government agencies. Yeah, that's what I want to say. Thank you.
Well, I guess the pandemic has kind of brought forward these opportunities to students to kind of start having, accessing all these software from home, and you can actually conduct it across Zoom and any of these platforms. Okay, cool. So yeah, next, who wants to go next?
Okay, maybe I can go next. I hope my perspective can complement what Noah has shared just now. I think he has shared a lot really about, not so much about the technology itself, but I do think that in this community, there are different roles that we play. So I think from where I'm coming from, I'm looking at it more from the implementation point of view, where, after having awareness that location is important, geography is important to the things and processes, I think the next level is really looking at the specific techniques and skills in creating, making use of GIS to facilitate some of the things that we do. So where I'm coming from is really on in terms of the hard technical skills, because GIS has been part of my formal education. So we spend a lot of time on managing and handling spatial data, because spatial data is different from the usual tabular data that most of us are familiar with since the younger days. We make use of Excel, draw a table, structure it. Spatial data is a little bit different, therefore it requires more specific techniques and skills to handle them. That's where we spend a lot of time on. I do like to focus on this because nowadays a lot of we hear a lot of the buzzword, of course, like you mentioned, also on AI, machine learning, making use of imagery, and also perhaps image detection, natural language processing, etc. But at the core of it is really about data, understanding data, and then being able to manage and handle such data. Just by knowing how to handle and manage spatial data in itself, I think there's a lot we as individuals can contribute to problem solving. So I'm not sure if any of you is actually following the news on the flooding events in China recently. So the Henan province is having this once in a 1,000-year floods, extremely serious, and also in the process, I think what I have observed as an outsider is that you see a lot of incidents of citizens helping fellow citizens. You also see some of the interesting things coming out where you have the real estate companies building this map of where are the people asking for help and where the rescue team have not reached. So these are really self-initiated GIS projects because of the skills that they have, because of the resources and data that they have. They created such public engagement platforms to help themselves, also to help the rescue team to reach out to those people who might not have been helped before. So I do think the ability and the skills to handle spatial data in itself creates a lot of possibilities for these amazing civic initiatives that allows you to tap on greater potential of geospatial. And other than that, even closer to home in Singapore, I think as we talk about newer developments in technology such as machine learning and also image detection, I think some of you might know of the initiative by MParks called Safe Distance. So there was something that is basically an app and a mobile, a web page where the public can assess and look at the level of crowdedness in different parks so that they can decide when and which part to visit to avoid the crowd. So I also read recently that MParks make use of machine learning algorithms to process the images so that they can automatically update the level of crowdedness in the park. So I feel that these new technologies coming to strengthen the entire system of GIS, how we can make, how geography remains relevant, but it's being even strengthened by some of these new developments. Yeah, so I thought that's something interesting. And there are a lot of such examples if you pay closer attention to the developments worldwide. There are really a lot of these interesting initiatives where geospatial comes in to help each and every one of us in our daily life.
Yeah, just to add on to that a little bit, one of the things that's really interesting is one of the first applications of GIS was a health application. So it was tied to the Black Plague in the Middle Ages, and they were mapping out where all the people were getting sick, and they didn't know what was causing the plague until they mapped it out, and then they realized that it was coming from the water. And by just placing those locations, many people would not think that mapping and health goes together, or disease goes together. But as we see right now, like I'm in quarantine, I'm locked in a room, I'm being isolated, and we implement travel policies in order to impact or provide a safer environment for the population, and that's using basically spatial technology, spatial awareness. Where is the disease coming from? And they say stopping flights, for example, and from certain countries. And the other interesting one is when you were just talking about the flooding. When you start thinking about flooding, that's also another opportunity where you're overlaying multiple data sets on top of one another. So it's important to understand where the rain is happening, and what the hydrology is, what the topography, as well as where is the population, right? So understanding all of those things is going to allow you to deal with a flood more effectively, so you don't waste time going to an area that's flooded and there's no one there and no one lives there. Or understanding that if there's rain up you know, in a certain part of the mountains downstream, you're going to get a big flood in due time. So it's important to you know, let those people know in those communities and how to create those types of alerts. So all of this is tied to GIS and mapping. One of the other, I guess in terms of one of the challenges, I would say, you know, we think about mapping, it is very much a local application. And that goes down to the map projections as well. So, you know, in Singapore, there's a standard projection. In the US, it's a little bit more complicated because each state, there's, you know, 50 states, each state will have its own map projections. And that's going to have a higher accuracy map for that specific topography in that state. But if you wanted to map the full country, you would use a different projections, like WGS 84 as an example. And one of the challenges that I've experienced, and I'm not sure if any of you have gone through this, but there's a, you know, GIS, I view it pretty much as data integration in many ways with a location component. And when you start integrating various data sets, one of the big things that will happen is you'll find all of a sudden you're integrating data sets with different map projections and things won't line up. And that's like the #1 mistake that people make in the industry. And I've seen it over and over again. And whenever someone's having a problem, the map's not lining up, I say, just check the projections. And what's interesting about that is two factors. One is it's a challenge, right? But it's also, it points to one of the strengths of mapping in that it's truly local. It really is a localized thing where you want to understand your local location better than somewhere else, if you will. Now, it may be important to understand the whole world, but what's really most important is what's close to you. And I like to use an example of point of interest data for that. So you can have relevance as or ratings as a review for something, let's say like a restaurant. So if I had a search, someone searches for sushi restaurants, I could say, okay, I'm just going to send, let's say Noah is searching for sushi restaurants. I'm going to send Noah the one that's got the best ratings, but that just happens to be in Japan, but it's got the best sushi. So you should be interested in that. Well, not really. If you're in Singapore, you want to have a sushi restaurant that's close by. So you're not searching for the best sushi, you're searching for sushi to eat. And so there's a spatial component to that, and there's also an application component, whereas I may be looking for a certain type of device, and I don't care where it is in the world, but if it's a restaurant, I do care. And so being able to classify those different types of businesses based on the spatial relevance and the spatial importance of that business as another layer, which could then drive how I get results back. It's an interesting aspect of it all. And then the other thing I'll mention is in terms of time series, I really feel like that when you start combining time, particularly with satellite imagery, that's really where you start to see a lot of interesting, you get a lot of interesting insights, because what's important to all of us, there's an element of the present state, which is important, but understanding where something is going or how it's changing over time gives us new insights and allows us to predict a little bit as to what's going to happen next. And that's where we start looking at a time series, particularly of imagery, as another element of the question here, integrating imagery in a time series of imagery, which we can then use to see how environments are changing or how populations are shifting. You know, one of the things that we were doing when I was spending some time at Google is we were looking at ways to look at urban sprawl in big cities, and we would use the imagery as well as population data to try and predict where the sprawl is going to go to next. And that becomes incredibly valuable from a real estate perspective or planning infrastructure. Where do we want to put the electric utility lines? So I was working with the electric company in California, and they were trying to figure out where to put the car recharging stations for electric vehicles. And they're saying they're at a 20-year plan. So knowing what's happening today is nice, but they need to figure out what's going to happen in 20 years. And by doing a time series for the last 5 or 10 years, they can see the trend of where it's moving to and plan their infrastructure appropriately. And then they would tie in other aspects of it, like how fertile is the land, how, you know, all the other aspects of proximity to other elements that would drive population centers. So all of these things can be applied to telco, to utilities, transportation, real estate planning, you name it. Everything and anything has that location element to it. And when we start adding in all of these other data layers, and then perhaps put a machine learning model on top of that to try and help us predict that, we get new insights and allow us to predict and plan for the future more effectively so we can have a more prosperous society.
Can I add on something? Because I was listening to what Yuting and Clinton said, I think there is something that in common that I would like to highlight. I think Yuting was saying about the importance of knowing how to manage and handle data, and Clinton was also sharing some of how some of the data can create new possibilities in research. So I was just also wondering at this point of time, because this was a struggle that I did face during my studies at NUS, and I still am facing this issue here as a teacher, is the availability of data. Because while we all recognize that spatial data are important, but its availability can pose a significant problem. So and not just availability, but I was also thinking about the recency of data, how recent this data are, and its accuracy. So yeah, this is what I struggle with. So if Yuting and Clinton could hop on, I'm not too sure, but that's a problem for me. So I don't know how you solve this challenge. Yeah.
Maybe I'll chip in a bit. So I guess I think it's definitely a challenge, not just in Singapore, but many other countries, especially developing countries. How can we get all these geospatial data? And I guess that's where I think governments right now are starting to recognize the importance of open data. And for once, I think definitely for Singapore, we are moving into the right direction. In Singapore, we have the open data, data.gov.sg, where you have access to I think a lot of different sets of government data, which are open data sets, and I think quite a number of them are actually geospatial data. And then of course from SLA, from the Singapore Land Authority, we do have one map, which is a public map that it is open. You can actually use the base map. You can actually use get access to some of the POIs through the use of APIs, and then you can actually import that into your apps or a GIS tool. Any other insights from Yuting or Clinton on this matter regarding data? I mean, definitely, I think geospatial has kind of given us a new challenge, a new headache, which is actually the size of the size of data that are being generated today.
Yeah, I mean, the accuracy issue is a big issue, and what's really interesting about that is, like, if you look at a dynamic map where you start off way out and then you zoom in, and people will say, well, how accurate is the map? And you say, well, it depends, and it depends. Well, it depends on, if I start off at a certain level, it's maybe 1 kilometer accurate. So any point in the map is within plus or minus 1 kilometer, and people say, well, what good is that? But if I'm looking at the whole world, like, it's very difficult to have something very accurate. But then once I start zooming in, at each level that I zoom in, I have a higher and higher accuracy. And then the other interesting issue with accuracy becomes when you start doing machine learning models, and you want to have good training data, and you're trying to measure something on the ground. So let's say right now we're doing a lot of work with forestry and carbon sequestration. And so if we wanted to measure a forest, and we're saying, okay, this tree is, say 10 feet tall and 4 feet wide, and I'm looking at that satellite image, and that, but the positional accuracy of that is 20 meters, I could be training the model to be completely off on that data, right? And so it's not actually, it's not useful for me, because the the accuracy of the data is less than what I'm actually measuring, and therefore I could be training the model incorrectly, right? So one of the things, there are some things you can do, Noah, to that, and particularly I can talk more towards the imagery side. But you know, one of the things is there's absolute accuracy. So if I say the absolute accuracy of the image, when I'm pointing at taking a satellite image of an area, I know it's the entire image is plus or minus, say, 10 meters. But within the image, measuring from one object to another spot in the same image, that's what they call relative accuracy. And that could be much, much tighter. So I know the distance between two objects, but I'm not exactly sure where those two objects are, is another way of putting it. And then what we can do is we can then take positional points that we know of. So let's say like we know exactly where SLA's office is, and we know exactly where the Merlion is, and we know exactly where certain points are, and we can take that image and squeeze it and stretch it to those points to make sure that those coordinates are accurate and correct for those positional inaccuracies. And that's one way to correct for some of the challenges that we face for positional accuracy. But it's still, to this day, it's a very difficult thing, and it's something that you know, I have battles with folks at times because they say, well, why don't we just use this free data? It's like, well, it's not accurate enough. I mean, I'm not talking about the Singapore. I'm talking about like some of the free satellite imagery out there. It's great, but it's 30-meter accuracy. So I could think I'm here, but I'm really across the street. And this is what happens a lot of times when we're on our phones and we're using the GPS and it jumps back and forth. You know, people will say, well, what's the positional accuracy of the GPS versus the cellular tower triangulation versus Wi-Fi versus Bluetooth, right? It's in that order. That's you get better and better accuracy, but you may not have access to some of the data where you are at that particular point, which is once again a spatial challenge, right? So spatially, you don't have access to the information that's going to enable you to get more accurate data, like say a Wi-Fi signal. So it's really an interesting thing, and then when we make that data available to what I was saying is like getting that data out there for applications in schools, and you know, from an educational perspective, that's really where we have the ability to innovate, right? Because very often the cost of getting some data sets is greater than the value that you're going to be able to get from it, at least initially, and that you perhaps need to build something with that data first and validate it before you can justify its expense. And this is one of the challenges, I think, with commercial imagery, where it can be very expensive. And if you want to build a model and you need thousands and thousands of images in order to build an accurate model, it doesn't make sense to spend $1 million to build a model and not even sure if it's going to work. So this is one of the challenges, one of the great things that Singapore has done in terms of making that data available, because it enables that innovation. It enables people to be creative and find new ways to use the data.
So maybe just to add on to that, Noah, I recognize that this is a very important question, also a very valid question, especially for students who have to do, you know, one project every module. You know, you always get into this question. But I feel that there are two levels to this question. One is that, you know, data is available, but somebody is holding it, is not shared. Okay, then the next level is for certain data sets, it's just not available. Nobody is collecting it, so such data sets just don't exist. So for the first type of data where, you know, somebody actually has it but it's not shared, I think generally what we see is that it's getting better everywhere. So increasingly people are recognizing the importance of open data. So also in a lot of countries, we do have these open data initiatives. In Singapore, like what Azam mentioned, the data.gov.sg is where you can find a lot of these infrastructural data. Again, definitely it's not everything that we have. There are some data that for some reason it's not shared because of commercial interest, because of personal privacy, etc. So that is one level of the question. The next level is really certain data sets are not just being collected. So I think increasingly also in the academia, it's being recognized that the efforts, we need to spend a lot more efforts in data collection. Instead of focusing on, you know, pushing the frontier of methodology, algorithm, and technology, I think we also need to devote some efforts into data collection, because certain data is just not there. It's important, but it's not there yet. So this effort to, I think we do have to think about how perhaps maybe from the government perspective or from the commercial enterprise perspective, how can we come together to identify some of these data sets that are important, but they are not there yet? So I do think parts of the efforts from the geospatial community should also look at that direction.
Yeah, I think definitely a very, very interesting insights from everyone. I think it's also very important that, as what you think mentioned, the availability of the data is one, how detailed the data is, how accurate the data is. I think right now we are actually moving into acquiring hyperlocal data. We are moving into much more deeper for a particular point of interest. We don't want to know just where's the location, but we want to know the characteristics of that particular location. Where is the entrances? You know, what is the closing, opening time? And these are definitely very, very relevant geospatial hyperlocal data. Okay, let's move on to our last question. How would you explain spatial thinking to and GIS to a non-GIS users, to someone who's a beginner? And how do you think spatial thinking can be more pervasive in organizations or schools?
Oh, okay, maybe I'll just answer the second question. So I would say that many teachers are now receiving training and coming on board the GIS in MOE. So for me, it is not about let's do more. I think it's about, hey, we have GIS. Now, how can we use that in more strategic ways? So really, in a sense, let's improve on what we have and what we can do better. So for me, as we have mentioned about data just now, right? I find that partnerships with organizations really helps to sort of situate students' learning in a very purposeful and meaningful way. So for instance, at CPDD, which is the Curriculum Planning Division, I got to receive a set of data from the Municipal Services Office, where they collect public feedback on municipal issues. The great thing about this set of data is that every feedback has a specific location. So it can be streetlights breaking, branches breaking off, pigeons in an area. And for me, I find that set of data very interesting because it really empowers students to see themselves as environmental citizens and how they can enhance the livability of their neighborhood. And this really helps to make their learning come alive. Yeah, so in that sense, when schools get to work with organizations and students handle the data about their environment, then I feel that their learning have a concrete impact. So this sense of knowing what matters and who they can reach out to meet specific environmental goals is really important because it equips them with skills and networks and like connections to help them to be really active members of society. Yeah. So this idea about data sharing through collaboration can really make a difference in the child's learning. And when other teachers see the benefits too, I feel that they can be inspired to change their own practice too. Yeah, that's what I would say. Thank you.
I'll jump in a little bit. One of the things that I think is probably necessary for us to really achieve scale in the space is for mapping in and of itself to not be its own industry, but to be a component that all industries integrate into their business, and having that same in the educational environment. So in other words, let's say if we're learning about the history of Singapore, we could see a map of, and part of the lesson plan will be maps and show how the country grew over time and developed. And then we go into, we start learning about the environment, and we learn about species of birds and different animals and where they all live. And then once again, part of that lesson plan is a map. And then we start talking about, perhaps in a business operations class, we start talking about, various things that, people want, whether it's finance or inventory management, those sorts of things. Once again, adding a map into the lesson. And I'm not sure if I think you mentioned this earlier of showing the map as a way to tell a bigger story. I think as we start integrating maps into the curriculum, not as a mapping class, but as an aid to help them better understand the subject matter in and of itself, then all of a sudden, spatial thinking will start to develop in the classroom and on almost an automatic way, rather than, okay, now we're going to learn about maps and then have that be the only time you learn it in school. I think maps need to be part of the curriculum across as many different subjects as possible. And then at that point, people will start thinking spatially, regardless of the subject matter.
I have heard a lot of good responses from the two other panelists. So perhaps something that I want to add on is that I think, of course, we talk a lot about how geospatial is a specific technique and skills, etc. But I would like to also highlight that I think the thinking spatial is something that is accessible to everyone. I especially like this sentence from the synopsis of today's session is that everybody is a GIS user, no matter whether you are aware or not. I think it's true because spatial thinking is everywhere in our life, in everything that we do. So it could be as simple as reading a MRT map. Just by looking at MRT map, that is already a manifestation of thinking spatially. So in how do we make it more pervasive in schools and organizations? I think I would say the first part is to demystify the concept of spatial thinking. We need to show that it's something that is accessible to everyone. It's something that we are already doing, just that we perhaps need to make it a little bit more specific. So then coming next, I think it's also important to build the spatial literacy and also building a culture in the team, in the organization about talking about spatial, talking about talking and thinking in a spatial way. So I think having that community, having that particular culture of looking at geospatial stuff is important to making it a more pervasive culture in the organization and school. I also think perhaps it's something somebody like me who is doing implementation. When we build geospatial platforms, we build applications, etc. We want it to be useful so that when users use them, they get something out of it. It can help them with certain things that they do. But I think in terms of these development efforts, I do think emphasis should also be placed on user friendliness and user-centric mindset, so that an initiative is only useful when somebody is using it, and it's only when somebody is using it they can start to develop, and it can be more pervasive in this community that thinking spatial really helps them with their businesses. So these are just some points that I could perhaps bring out based on my own experience of working on these projects.
Thanks. I think definitely. I think we've had a really good insights and experience being shared in the past 45-50 minutes. Let's move on to a quick Q&A. And let's answer some of the questions that have been posted by some of the audience. We've got one question here. Will there be some investigation into whether the digital learning program will enable a greater use of GIS or geospatial learning in the classroom? I guess I think Noah would probably be the best person here to answer this question.
Actually, I am also not the best person to answer because I am in schools. I'm not at MOEHQ, but I guess to respond to Bob's question, maybe just a background. I think that due to supply issues, schools not all the schools have gotten their laptop. So I think we are moving in stages. Even my school, we have not, the students have not received their laptop. So this question about the investigation about whether it will enable more use, I think we have to wait till all schools receive their laptop. That's what I think. That's my answer. Yeah.
Okay.
Yeah. Back to you.
Yeah. One more last. I guess this would be the last question. We are kind of running out of a bit of a run of time. This is actually quite a long question. The notion of spatial thinking and applying it in real life is still uncommon to some people, be it young people or senior corporate government leaders. Although there has been some studies that show there is a multitude of benefits by integrating spatial thinking, what are the challenges in turning this, nurturing and applying spatial thinking into realization? How can we as GIS practitioners and educators help to contribute in addressing this issue in the present and future? Would like to hear perspectives from academia and industry experts. I think a lot of we probably have discussed, I think, quite a bit of the answers to this set of questions here, but maybe I'll open it up to the panel to kind of sum it up before we close this webinar.
I would just say really quickly, I think that the biggest thing for you to do, to the person who's asking the question, is to identify the current data sets that you have in-house right now and try and get them as structured as possible so that you can easily load them into a GIS. And then once that's done, you'll be able to start doing things relatively straightforward. It shouldn't be as difficult as many will think. The biggest issue is just getting the data cleaned up and in a format where you can integrate it in quickly.
Maybe I would like to top it up. I feel that GIS users, even Yuting herself, I think we need to have the white space to reflect and update our own skills, because, for instance, I think recent Azure user conference, there are many new functions in the future upcoming ArcGIS Pro. So for myself, I attend the user conference at night after planning all my lessons. So I think having that white space to look through, to reflect and think about how we can bring this to our own work is actually very important, because we need to settle our bread and butter first. Yeah, that's what I would say.
Okay, I do think it's part of it is data, like what Clinton mentioned. But as a whole, it's really about encourage more people to join. I think it's also about having that resources ready for them to exploit. So data is part of it. Platform technology is also another part of it. How do we make it easy to use for the general public, so that they don't feel that the threshold to enter this space is so high that they don't even dare to try. So I think it's about bringing that technology to the people so that more people can join this community.
Okay, with that, I think we've come to the end of our Fireside Chat. I would like to extend a very, very big thank you to Noah, Clinton, and Yuting for giving us all these great insights from the perspective of an educator, from a student, and right now who is getting into being a practitioner, and then Clinton being a veteran in this industry. I would like to thank everyone, and to all the attendees, thank you so much. If you do have any further questions, do reach out to us over at GeoWorks. Do send in any questions that you may have. And with that, I'd like to say thank you and have a good afternoon.
Thank you.
Okay, thank you.
Thank you. See you guys. Bye-bye.
Thank you. Bye-bye.